The world of electronics is on the cusp of a revolution. Artificial intelligence, or AI, is rapidly changing how we design and manufacture printed circuit boards, or PCBs. These intricate boards are the backbone of every electronic device. From smartphones to spacecraft, PCBs are essential for connecting and controlling electronic components. AI is poised to make PCB design faster, more efficient, and more precise than ever before. This technology goes beyond traditional design tools. AI algorithms can analyze vast amounts of data, learn from past designs, and make intelligent decisions. This capability opens up exciting possibilities for innovation and optimization in the electronics industry. The integration of AI into PCB design is not just about automation, it's about augmenting human capabilities. AI can handle repetitive tasks and complex calculations, freeing up engineers to focus on higher-level design considerations. This collaboration between human expertise and AI's computational power is key to unlocking the full potential of this technology. As we delve deeper into the world of AI-driven PCB design, we'll explore the specific ways AI is transforming each stage of the process. From schematic capture to manufacturing and testing, AI is set to redefine the landscape of electronics design. Imagine a design process where AI assists engineers at every step. This is rapidly becoming a reality in PCB design. AI algorithms are being integrated into software tools, automating and enhancing traditional design stages. One area where AI shines is schematic capture. This initial stage involves creating a blueprint of the circuit's electrical connections. AI can analyze component libraries, suggest optimal placements, and even detect potential errors in the schematic. This assistance accelerates the design process and reduces the risk of human error. Layout generation, a crucial and often time-consuming stage, also benefits significantly from AI. AI algorithms can analyze the schematic, consider design rules and constraints, and automatically generate an optimized layout. This process ensures components are placed efficiently, minimizing signal interference and ensuring the board functions as intended. Routing.